All right. Hi, I'm Tim. You've all seen enough of me today, but I'm actually going to talk about something Postgres rather than logistics. And that's the 1600 column hard limit. Does everyone know what I'm talking about? Okay, not many people know what I'm talking about. Postgres has a limit of 1600 columns. So if you have a table with more than 1600 columns, you are basically screwed with the way it works right now. And some people might say you're absolutely insane for having more than 1600 columns, but remember, it might not always be the person administering Postgres' choice on whether to have 1600 columns. And I wanted to look into this as to why there was a 1600 column limit, because I had no idea. So I decided it would be an interesting thing to look into, because my team has to manage about 30,000 tables that come from different data vendors, and we've gotten all of them into Postgres, except for like 6 of them, which really kind of sucks because we've been migrating all our data from SAS to Postgres, and it would be really great if we didn't have to tell some of our users. So you can get to 29,994 tables, but if you want the other 6, you'll have to figure out SAS and how to use it. So the first question, but why? So I started digging into the actual Postgres source code, and in there is this handy little comment that says the key. The key limit on this value is that the size of the fixed overhead for a tuple plus the size of the null values bitmap at 1 bit per column plus max align alignment must fit into t_hoff, which is uint 8. On most machines, the upper limit without making t_hoff wider would be a little over 1700. So what this means, after a little more Googling and a little more self-education, is that it might be possible to change t_hoff and a couple other places in the code. It wouldn't be a huge pull request to a uint 16 or 32 or 64, and thereby increase double, triple, quadruple the amount of columns supported. The downside of this is if we were to change it from a uint 8 to a uint 16, for example, would be that it would add a single byte to every row in the database. This, a single byte might not seem like a big deal until you realize that if you have a billion rows, you then have a gig added to that table. So these things, so it's a trade-off. It's a trade-off consideration. And the core team has put a lot of effort into trying to keep the size of that field as small as possible because it's required for each row. Okay, but let's take a look at some of the competition out there. So the column limits by database for Maria and MySQL running MyISIM is 4096. Microsoft SQL Server can go up to 30,000 depending on the column type. And SQLite can go to 32,767. So it does seem that while we have saved some bytes over the years, it might be nice if Postgres could at least have an option of some kind to allow us to break that 1600 barrier. So a few ideas we had on solving this before we even started looking at increasing the column type. Make it a view. That was our first idea. Split it up into a couple tables and then have a view which will join them all together. Unfortunately, that would not work because views have the same limitation of 1600 columns. And we also thought use a JSON field or an array. But this would change how our users, again, just query those couple of tables completely differently than the other approximately 30,000 we have. So it would really kind of suck to say, oh, if you want to use these, once again, you got to break out to it. And good luck trying to teach them how to do joins and things. These are PhDs in finance, so they are not the brightest people in the world. So then I took to Google and found some kind advice from Google searches because, you know, the internet's such a beautiful, loving place. So I went out and decided to try to get some help from Google. And I found a couple things like, re-architect your data! That's sloppy design, and who the hell would do that? So it's really not a viable option for us. We have some concerns, so we don't control all the documentation from some of our data vendors. The customer experience, as I mentioned, would be different, and people with less SQL experience would struggle mightily with yet another thing to learn that would get in the way of them doing their research. We also don't control all the source data. You know, one of these products comes directly from the US government, the Bank Regulatory Database, which has over 6,000 columns. And we're not very likely to convince them to change after they've been doing it this way since the 1970s. So really our hands are kind of tied here. We've also had, we've had some of our paying customers say that in their industry, this is just a showstopper for the way their researchers work. They're used to denormalized data, they're used to Excel, they've had 30 years of thinking this way, and part of the value we bring is sort of having these denormalized wide tables to them so they can just focus on their research and their way of doing things without having to learn something new or break up the way they do things. So I gotta admit, I'm a web developer by trade, so I tinker with a lot of things across a lot of different industries, but I am way out of my web dev comfort zone here. And I remember that even though I've been programming for many years, that you should never be afraid to ask your friends for help. So I did some more digging, and these are some of the many things I do not know. So first of all, I asked myself what this 1600 column limit created years ago when computer resources were very different. And it was. I found a thread from 2001 where Bruce Momjian, who's right outside Philadelphia and core committer of Postgres, was actually addressing this very issue. And I thought, oh great, it was probably just a random number some developer picked back then thinking no idiot would ever use more than 1600 columns. That was before I found out that it would actually add a byte or more to every row. But this question has been being asked for a very long time, so there are clearly people more than just me who have this concern. So I thought, could we change thoff to be a uint 16, 32, or 64 instead of a uint 8, or change our block size to 32K instead of 8K? And what are the performance or other ramifications? Would there be data loss ramifications? Would it be dangerous for somebody like me who doesn't understand all the core arcane sorcery going on in Postgres to start hacking around on the code and compiling my own version? I also wondered, could this just be made a .conf option? So anytime there's a new Postgres release, I don't want to have to monkey patch it to make this work. And are there any elegant solutions I'm missing to achieve over 1600 columns that would not, given the concerns I've stated, that would work? And I don't know, there may be. It's quite possible I missed something. But I also found a starting point here, instructions for increasing the maximum number of columns, which seems to be a pretty good walkthrough on how to actually modify the source code to do it. So that leaves me with my final slide, help. If anybody has any ideas on how to accomplish this in an elegant fashion, by all means, please see me after we're done here. And I would love to chat with you, or if you'd like to contribute on trying to make this either a compile time option or a configuration file option, or even at best, what I'd love to do is have this an option created during the create table syntax, so it only applies to certain tables. I would love to chat with you. Thank you very much.